So go ahead, Juan.
Thank you, Gilbert. Thanks for joining me today. I am Juan Carlos Ramos. I work as the on-farm research coordinator with the Nutrient Management Speed Program, NMSP, at Cornell University. This is the Value of Manure project, and I've been working closely for this project with Kirsten Gorman, Senior Extension Associate with ProDairy at Cornell, and my team lead, Quirin Caterings, and also a lot of help from our team members in the NMSP, staff, interns, so very grateful for their help. So I'm gonna start with an overview of New York dairy agriculture. This is a map of New York State, and you can see the distribution of CAFOs on red, large CAFOs, on green, medium ones. We have around 3,000 dairy farms in the state. Around 500 of them are CAFOs, so a good distribution of those farms across our state. New York dairy is very important there for our state. I think New York breeds dairy is an important driver of our rural economies, also our rural culture. So I think it's very important there. And in that context, our team, the NMSP, works on addressing relevant questions and conducting sound science for agricultural profitability and protection of the environment. So our value manure project, to give you some context, in New York we have a nitrogen crediting system that says from the total nitrogen that you're applied with manure, how much is actually going to be crop available, and CAFOs and farms use this in the nutrient plants. And it recognizes that manure has nitrogen in two forms, organic and inorganic. For the inorganic one, is readily available for the plant. And the share of that total nitrogen that is going to be, of inorganic nitrogen that is going to be available for the plant depends on when it is applied. More nitrogen is going to be available if we apply in season versus if we apply in fall. Same for then the inorganic section. We have two here. So a section of the inorganic nitrogen is going to become crop available the year it is applied. Right now, we say that more is going to be available if it's a liquid source versus a dry one, a solid source. And then for the other inorganic section, it's going to be available a year after application and less 2 years after that application. So slow release fertilizer. And then the seed of this project begins on 2016 when we conducted this trial with one of our farms collaborators. This is actually a plain pictures. Drones weren't a thing back then. And we apply manure in 3 strips. You can see the arrows there. And then 3 strips didn't receive manure. You can clearly see the ones that did receive it. They're greener. And then at side dressing times, each of those strips was subdivided into 6 sub-strips, and they received different side dress rates between 0 and 175 pounds. So I want you to pay attention to this section. We have the 0 side dress nitrogen plots next to our maximum nitrogen rate. And you can see that still the 0 one was looking greener than our maximum side dress rate. So when we move into the results for those trials, we conducted research 2 years there. On the second year, we had 2 trials with 2 different varieties. These are the nitrogen response curves, yield on the y-axis, nitrogen rates on the x-axis. And on gray, we have the no manure strips. On brown, the manure ones. You can see that there was a nitrogen response in the no manure strips. As we increase hydrous nitrogen, yield was increasing till it reaches a plateau. But in the manure strips, we didn't see a nitrogen response. Manure supplied all the nitrogen that the crop needed. But also interestingly, in the 3 plots, there's a yield gap between those 2 treatments. So a yield increase due to manure application, in those 3 sites. So for us, that was very interesting to see. And we have some observations. Our current crediting systems, the one I was explaining, the science behind that comes from the late 80s and the early 90s. Now we have new technologies in the farms, treating manure, how we manage manure is different today. Also how we apply manure has changed. And yield bumps, the ones we observe in those trials, are not taken into account into our crediting system. So with that, on 2022, we began the Value Manure project. It's been running for 3 seasons, and we are going to conduct one probably last season this year. And addressing 2 knowledge gaps. One is we need information about how manure looks today to credit it accordingly, taking into account those treatment and manure application methods that are farms are using today. And we are also looking at what the economics, yield, forage quality, benefits of using manure replacing inorganic fertilizer nitrogen. So the plots look very much the same as the 2016 ones. So here we have 3 strips with manure on blue, 3 strips with no manure on yellow. Then this is actually a satellite image of one of our sites. You can see here the drier strips where the farm didn't apply manure. They went and applied manure to the rest of the field. And then at side dressing time, where the corn is in the B4, B6 stage, the different side dress rates are applied. So in this case, the farm was applying rates between 0 and 175 pounds of nitrogen. This range is different for each of our trials. We try to move them accordingly to the nitrogen needs we expect for each of the sites. Between 2022 and 2023, we had 11 sites with a good distribution across the state. And last year, we had 11 more trials. This is research happening on farms, and I think it's very important for this kind of research because we are able to test different soil characteristics, fields with different manure histories, with different weather conditions that we have in the state, different agronomic managements. Just there with those videos, you can see that the farms had different systems, agronomic systems as well. Different manure sources that the farms have today and the application methods and timings they're doing. And also, we think that there's a lot of benefit in having this two-way learning process where we conduct research in farms. We get to see what are the challenges, opportunities that farms have, and also help us with our extension message when they have homegrown data. So what kind of farms we were working with? 11 farms had liquid manure, 6 digestate, a couple compost. The application rates, 30 tons an acre for our compost ones, 1 farm below 5,000 gallons an acre, 9 farms with rates between 5 and 10,000 gallons an acre, and 7 farms with rates between 10 and 15,000. The application method was mainly injection, followed by broadcast plus incorporation for 8 sites, and a couple of sites that only broadcasted manure with no incorporation. Moving into their results with our nitrogen response curves, now we are calculating the most economical rate of nitrogen. We do this based on these numbers, the cost of a pound of nitrogen, the value of a ton of silage or a bushel of grain, and we basically calculate what's the point where adding extra nitrogen doesn't pay for the extra yield increase. So here on gray, we have also no manure, and this is the MERN point. So this means that for this trial, we needed 114 pounds of nitrogen for a yield of 28.5 tons. Versus in the manure ones on brown, we needed 56 pounds of side-dress nitrogen, so less side-dress need for a yield of 29 tons, a little bit higher. So when we look at those numbers and then we see the gap between the two MERNs, we can calculate how much inorganic fertilizer we replaced. So in this case, 58 pounds of fertilizer nitrogen were replaced by the manure application. Now moving into more of our results, we are grouping them into different responses that we saw. This is the first one. There was no response to the nitrogen that we applied. So as we increased the rate of inorganic fertilizer, there was no yield increase. And there was also no response to manure. So the yields were the same between manure and no manure plots. Here, interestingly, on green, we have New York State average. These fields are way above New York State's average. And we see that here, these are higher yielding fields that have seen a longer manure history. So the soil already has enough nitrogen to supply the crop, so it didn't benefit from neither manure or side-dress application. Then we have trials where we saw a nitrogen response and a yield bump similar to my MERN example. I won't go into detail for each of them, but we are seeing that manure is replacing fertilizer, is increasing yield to levels that are not achievable with inorganic fertilizer only. So that's a very positive story that we are seeing in several of our trials as well. Another scenario, a big yield bump. So there's quite a gap between these two MERNs here, but also that came with a higher need of inorganic nitrogen. So interestingly, here, for example, we needed 113 pounds of fertilizer for a yield of 17 tons, versus in the no manure, only 12 tons and a half of yield, but almost 50 pounds less of nitrogen needed there. Something similar here, we needed 90 pounds versus 103 in the manure plots, so 13 extra pounds of side-dress nitrogen in the manure plots. But there was a yield difference of almost 21 bushel, so bigger yield increase. We have the hypothesis that, well, these sites were in the medium level for potassium, so probably manure was also addressing that potential deficiency and unlocking extra yield that came with an extra nitrogen need. These two trials were conducted on 2023. On 2024, we were able to conduct research on the same sites, now with no manure application, just looking at the carryover benefits of the manure that was applied the year before. And still, we were able to see the positive impact of that previous year manure application. So the yields here are 23 tons and a half versus almost 21 in the no-manure one. So a yield bump, nitrogen needs were very similar. And the trial on your right, also a yield bump of almost 14 bushel, and actually a higher nitrogen need in the manure plots, in the no-manure plots. With the difference that this year, because we had that hypothesis of the potential potassium deficiency, in the spring of 2024, both farms did a blanket potash application. So we were trying to only account for the nitrogen value of manure in these yields. Results to date, yield response to manure and nitrogen is site-specific. We saw nitrogen responses and yield bumps in 9 of our trials, no nitrogen or manure response on 3 of them. These are high yielding with larger manure history fields. A couple of sites with those large yield bumps and higher nitrogen side-dress needs. And we were able to conduct 5 carryover manure trials where we tested the benefits of manure on the second year, and on all of them, we saw a nitrogen and yield benefit from that previous year manure application. Then moving into our preliminary conclusion, manure can offset fertilizer needs, it can increase corn yield. That's also in year 1, also in year 2 after manure application. The response is going to vary by location and year. Field histories plays an important role in evaluating the yield enhancing effect of manure. Gurpreet Kaur is a PhD candidate with our team. She was able to do some soil microbial indicator sampling on 11 of our sites. She's looking at soil health, microbial activity, and microbial biomass. She's actually now conducting soil respiration and below ground diversity, looking at DNA, see what's going on in the soil. So we are very excited about that, and hopefully we're going to get some results out soon. Next steps, we are going to be looking into the silage quality side of all of this. We have been sampling silage quality. I need to summarize that data. Good with soil microbial health indicators. We want to look at the economics of using manure as a fertilizer, sustainability, nutrient efficiency indicators, field level nutrient mass balances, and generate tools to improve manure nutrient use in our state. We also now are starting the Power of Manure project. This is our flyer here, looking at how much nitrogen can my soil provide, how do past manure applications and management impact soil nitrogen supply, and also the microbial biomass side of this. Thanks to all of our funding partners, and especially to the farms and team members that have helped in this project. And with that, thank you, and open for questions.